Now that we have discussed about the coordinates and the x coordinate being called the abscissa and the y coordinate being called the ordinate, we have a specific terminology even for the point we refer on the Cartesian plane. Let's see how we can represent or use the terminology, the correct terminology for a coordinate in a Cartesian plane. As we have seen through the coordinates, here comes the importance of identifying the definition of ordered pair. As we all know that a pair is combination of two different objects taken together. Here the pair refers to x value and y value taken as a pair. So an ordered pair refers to the x and y coordinates or the abscissa and the ordinate taken in the bracket paired together. That is, when I take a point 2, 3, it indicates that for x equal to 2 is being paired with y equal to 3, and they are associated with each other. Every pair have a certain relation, and here the relation is that these two coordinates pair to form a point. So these two coordinates x and y are paired to form a point in the Cartesian plane. So here I have the Cartesian plane in which 1, 2, 3, 4. I clearly see my x coordinate, which is 2, and y coordinate, which is 3, are paired together to form a point 2, 3. The pair forms a point in the Cartesian plane. Is how we understand the pair. But what is an ordered pair? It is very important that when you take the coordinates x and y taken in the pair, reversed order will never be equal. An important note to be made in the branch of mathematics. The pair xy will never be equal to the pair yx because they maintain an order, and hence every point xy in the xy coordinate system or the Cartesian plane is called an ordered pair. The first value refers to the x coordinate and the second value refers to the y coordinate. Abscissa and ordinate are ordered, and xy cannot be equal to yx for all x and y belonging to R, is how I understand the properties of ordered pairs. The pair must be ordered. For example, 2, 3 point cannot be equal to 3, 2, which can clearly be verified because 2, 3 is here, and when I take 3, 2, I move 3 units right and 2 units down, and then I get this point to be Q. Therefore, my 3, 2 and 2, 3 are not exactly plotted at the same point. They are different from each other, which clearly proves that 2, 3 is not equal to 3, 2. Therefore, xy is not equal to yx. The 2 points are equal only when they are in order. Xy must be equal to xy, but xy cannot be equal to yx, is how I understand the definition of an ordered pair. An ordered pair and its properties. Let's see some properties connected with coordinates in the Cartesian plane. As we have discussed about the ordered pair in which x, y in a Cartesian plane can only be xy, but xy cannot be equal to yx. Say, for example, let me take the properties. If I take the ordered pair x comma y as a point and I say this is equal to the Cartesian ordered pair when it's reversed, then in that case this is possible only when x equal to y, is how we understand the property. This property can never be true if they are not equal. They have to be equal. If the abscissa and the ordinate are equal, only then I get the reversing property holding true. For example, let's take an example problem. If I have the property 3 comma minus 2, clearly when I reverse, we know that this when reversed gives me minus 2 comma 3. So the reversing of the point 3 minus 2 to minus 3 clearly makes me understand that 3 minus 2 is not equal to minus 2, 3. But if I take, say for example, another set of example which says 5 comma 5. I have the coordinate 5 comma 5 which I would like to reverse. So when I reverse the x and y coordinate, I get here again 5 comma 5. Therefore, in this case, my coordinate in which the coordinates are reversed are both equal. Therefore, in order that xy must be equal to yx, I should have the condition that this x and this y must be same. Xy equal to yx only when x is equal to y. If x is not equal to y, xy is not equal to yx, is how we understand the properties connecting the Cartesian plane. Now that we have discussed about the coordinate geometry, now comes on how we can represent the axes in different forms in real life. As we have discussed about x and y axis, x axis being the horizontal axis and y axis being the vertical axis, what would be its significance in real life? Let's see an example problem to understand this concept more better. For example, I have axis representation in real life, x-axis and y-axis representation in real life. For example, I have a table of time and distance, where t stands for time and d stands for distance, time in seconds and distance in meters, is how we try to connect. Say for example, I take a real life problem of a 100-meter sprint race where the Olympic participants tried to run in 100 meters. Usain Bolt is what I'm talking about. So here, let's try to take the time and distance problem in understanding the axis representation in real life. For example, say in the first 2 seconds, the distance run by the Olympic sprinters in average is 30 meters, 20 meters, and then say the distance run in 4 seconds by the sprinters is 39 seconds, 39 meters, and say in the distance run in 7 seconds is 71 meters, and the distance run in 1/8 second and the distance run in 10th second is say 100 meters. So approximately I would like to say that this is the table of all the time and distance. The first row refers to the time taken by the sprint participant in each of the seconds, and the second row represents his running distance of 100-meter race. So this gives me a picture of a real life problem, which I'm going to convert into axis representation. Quite interesting. So here the time refers to the first 2 seconds. The distance covered by the sprinter is 20 meters. Distance in meters, time in seconds. So the first 2 seconds, the distance covered by the sprinter is 20 meters. And for the first 4 seconds, the distance would be 39 meters as recorded, approximately. When the time taken is 7 seconds, it is assumed that the distance traveled by the sprinter is 71 seconds. For the 8th second, it is said to be 89 meters. And then coming to the 9th second, it is 94, and 10th second, it is 100. Is how I understand this in real life situation. How do you convert this into axis is the biggest question out here. In order to convert this into axis, we try to take always this is called t-axis because x-axis is now represented by the variable t. Your x is now the time in seconds and your y is now the distance in meters. So I have here the time which I'm going to denote with 2, 4, 6, 8, 10, 12. Now the scale. What am I going to do with the scale? As we have discussed that every graph has 1 centimeter grid distance, we just represent the 1 centimeter grid distance with different values as scale. So here, because my values are up to 100, taking each of the grid with 1 centimeter equal to 1 unit on y-axis becomes a tough challenge. Therefore, I increase the scale on y-axis. So each of the 1 centimeter grid is taken to be 25, 50, 75, 100, 125. So here I adjust the scale on x-axis, which is my t-axis, to be 1 centimeter equal to 2 units, and then on this d-axis, which refers to the y-axis, the distance axis is 1 centimeter equals 25 units. This makes me clearly understand that the scale is a significant tool in making the window setup so that I can understand how the different values can be adjusted through the scale. A scale is an important tool in adjusting the values into the graph. So here I have my t-axis, which refers to the time, and my d-axis, which refers to the distance of the sprinter in 100-meter race. So my time is in seconds and my distance in meters for the 100-meter sprint race. So let's see how I can plot the points. I can have my t is 2, my distance is 20, approximately here. My t is 4, my distance is 39, approximately somewhere here. My t is 7, my distance is 71, so I have this to be approximately here. is how I get. When I have 8 seconds reached, my distance would cover 89. I have this covered, and then 8 seconds is 89, which comes. And 9 seconds is 94. And 10 seconds is 100. Is how I make the distance time graph. This graph is called distance time or time distance graph, where this refers to t-axis and this refers to d-axis. So any problem in xy coordinate system can be applied in real life situation. For example, this being the time and distance of a 100-meter sprint participant in the Olympic Games. The chart of Usain Bolt.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.